In this video, we're going to look at the basics of exponential differentiation. So again, the rules for this come from page 25 of your log table, so make sure you have that with you. So our basic rule, where we have a function y is equal to e to the power of x, our derivative, and this is taken directly from page 25, is also e to the power of x. So an exponential function does not change when you're differentiating it. Where we see a change is where we have a number in front of the power. So where we have e to the power of ax, that means that we have to bring down the power, the number in front of the x, and multiply, so that becomes ae to the power of ax. You'll notice then in an exponential function, when you're finding the derivative, the power will always stay the same. So you differentiate your exponential function and you basically multiply the function by the derivative of the power. That's your quick rule. So let's look at a couple of examples. If we have, for example, y is equal to e to the power of 5x, that means that we're looking at dy dx. So remember, the exponential function does not change. We're looking at still e to the power of 5x, but we must multiply by the derivative of the power, which is our 5. So our answer there would be 5e to the power of 5x. We look at more complicated scenarios and where we have to use maybe the chain rule. So for example, if we have y is equal to e to the power of root x, so we know that that can be written as e to the power of x to the power of a half. So for the purposes of this one here now, I'm going to use my chain rule and replace that with an e to the power of u, where u is equal to x to the power of a half. I differentiate them separately. Dy du is e to the power of u. Du dx is a half x to the power of minus a half, and then we simply multiply them back together. So dy dx is going to be a half x to the power of minus a half times by e to the power of u, which is x to the power of a half. So again, we can see that our actual exponential function does not change, but we are simply multiplying by the derivative of the power. That's your shortcut rule for exponential functions. So make sure that you understand that fully. So where you have your basics, e to the power of x and e to the power of ax, those can be taken directly from page 25 of your log tables. Where you have something a little bit more complicated, you can use the chain rule or remember the shortcut. The exponential function stays the same, and then you multiply by the derivative of the power. Now, we also have examples where we have to use the quotient and product rules for exponential differentiation. So looking at this example here, y is equal to e to the power of 5x over sine x. So in this, we don't have any way of simplifying it or anything like that, so we have to use the quotient rule. So we start off by saying y is equal to u over v, where u is equal to e to the power of x and v is equal to sine x. We differentiate both separately. Du dx is 5e to the power of 5x, dv dx is cos x, and then we apply our quotient rule. Dy dx is v multiplied by du dx minus u multiplied by dv dx all over v squared. So filling it in, we have sine x multiplied by 5e to the power of 5x minus u by dv dx, so that's e to the power of 5x times by cos x all over sine x to be squared. Now, there's not much we can do in terms of simplifying that. All we can do is write it as 5e to the power of 5x sine x minus e to the power of 5x cos x all over sine squared x. That's one example of what we can do there. Another thing we can do is we can factorize out the e to the power of 5x, so I can change my top line there very, very slightly. Because e to the power of 5x is common to both, I can write e to the power of 5x by 5 sine x minus cos x. But that's all I can do in terms of simplifying that function. So that's a look at how to apply our basic exponential rules and how to bring the exponential rules into something like the quotient rule.